こんにちは、皆さん。Ms.P です。Hello, everyone. I'm Ms.P. Today, I'm gonna show you the relationships between the slope of a secant line and the slope of a tangent by using limit. So, originally, I made this video for my students, but I think this video will help you too. And the point is that I use very simple integers but not small decimal numbers, which is very different from most of your textbooks. And also I use a very easy function, which is f of x is equal to x squared, the parent function of quadratic functions. That will help you to understand the concept of this lesson better. So, let's practice! Okay, so now I'm going to explain to you the relationships between secant lines and tangent. So first of all, we have to understand this graph. This is the concept of secant line, and this is secant line, and secant line goes through 2 points on the curve. Okay, so this time I use a very simple function, very simple curve, which is f of x is equal to x squared, to make you guys understand much more easily. And then this point, x value is x, y value is f of x, and this point, x value is x plus h, and y value is f of x plus h. And the h is the differences between two x values, okay? H is the differences between two x values. And next, I'm going to show you the slope of a secant line. So slope of a secant line, m secant, m usually represents the slope, right? And then secant, the slope of secant line is equal to change in y over change in x, okay? Or we can say rise over run. I think this is very familiar. You guys are very familiar to this one, and then you should know this now. And then changing y over changing x. Changing y is f of x plus h minus f of x. F of x plus h minus f of x. All over changing x. Changing x is x plus h minus x. X plus h minus x. And I'm going to simplify this one. Is equal to, numerator will be the same, f of x plus h minus f of x. All over, so we can cancel h, right? So denominator will be h. So this is the slope of secant line. Okay, so now I'm going to use actual numbers, which is simple integers, for the points of the secant lines, to make you guys understand the concept much more easily. So I'm gonna say this point, actually x is 1. Okay, x is 1. So x is 1, so y should be, 1 squared is 1. So this point is 1, 1. And next point, I'm gonna say this point. This is a 2. X value is 2. So y value should be 2 squared, which is 4. And next one, this is the 3, and this point, x value is 3, and y value is 3 squared, which is 9. Okay, and then next one, x plus h, I'm going to say this is the 4, which h is equal to 3, because h, 4 and 1, the difference is 3. Okay, so that is why this is 4, and y value is 4 squared, which is 16. And now I'm going to find the slope of each secant line. So I'm going to find this slopes, this secant line's slope. So m secant, so changing y over changing x, so this point and this point. So 16 minus 1 over 4 minus 1, which is 15 over 3 is equal to 5. So the slope of this secant line is 5. And next one, so I'm going to draw the secant line here. This is the secant line, and then this the slope of a secant line is 9, this point and this point. 9 minus 1 over 3 minus 1, which is 8 over 2, is equal to 4. So the slope of this secant line is 4. And next one, this secant line, so this time the slope of a secant line is this point and this point, 4 minus 1 over 2 minus 1, which is 3. So the slope of this secant line is 3. And now I see the tangent line over here at this point. Tangent line attaches the curve at the only one point, okay, this point. So now we have to find the slope of tangent line, right? So slope of tangent line, m tangent, which is we have to take a derivative of f of x. So derivative of f of x is equal to, we're going to use limit, okay? We're going to use limit as h approaches 0. This is going to be the slope of secant line, f of x plus h minus f of x all over h. So this is the slope of tangent, okay? This is the slope of tangent. This part, the slope of secant line, once we use limit, the whole thing is going to be the slope of tangent line, okay? So now I have to plug x plus h into x squared. So let's see. Limit as h approaches 0, x plus h squared, and then minus f of x. F of x is x squared, so minus x squared all over h. And now you have to use for method, but I'm gonna skip to show you for method. So, and limit as h approaches 0. So x plus h squared is x squared plus 2xh plus h squared and minus x squared all over h. So now we can cancel x squared, right? And also 2x h over h, we can cancel h. And h squared over h, we can cancel h, and the power will be 1. So I'm going to rewrite this one. Limit, oops, that's okay, different color, but that's okay. As h approaches 0, 2x plus h. So as h approaches 0, this term will be 0. So it's going to be 2x. This is going to be 2x. And this is the slope of tangent. And now we can find the actual number of the slope of a tangent, because this tangent line attaches the point 1, 1 on the curve. So, and at x is equal to 1, and then the actual number of the slope of a tangent is derivative of 1. Derivative of f of 1, derivative of f of 1, which is 2 times 1, 2x, because 2x, 2 times 1, which is 2. This is 2 is actual number of the slope of this tangent. So the slope of this tangent is 2. So now I'm going to make a summary, okay? Now I'm going to make a summary. So x, h, and the slope of a secant line, okay? The slope of a secant line. So x is always 1, 1, 1, 1, okay? So 1, 1, 1, 1. So h is gonna be different. So h, then first of all, h is 3, and then moving to the here, and then at x is equal to 1, h is 0. So as h approaches 0 from 3, 2, 1, 0. So as h approaches 0, the slope of a secant line approaches, let's see. So the slope of the secant line here is 5, 4, 3. So 5, 4, 3. And now finally, as h approaches 0, the slope of a secant line approaches slope of tangent line, which is 2. You understand? And I hope this is gonna be very helpful. Hello everyone, how was today's lesson? I hope today's lesson was very helpful, and maybe I'm gonna upload some other mathematics videos. So see you later. Good luck. Nora, Nora, かわいいな、お前はかわいいな。